Of logarithms. What I want you to do is to go ahead and use your calculator to work each one of these out. So pause the video so you can do that. Use the log button on your calculator. Well, you'll realize that the first one here is false. The second one on the left is true. Third one on the left is false. And the bottom one is false. When you do the ones on the right, typing them in, you get these answers. Now this should all be review for you. So based on what you see here on what works and what doesn't work, and based on your prior knowledge of logarithms, go ahead and answer these questions. Well, when you have the log of two things multiplied together, you can go log of the first thing, then you go plus log of the second one. Now, when you're multiplying, you add. When you're dividing, you're going to still go log of the first one, but then you subtract the log of the second one. Now, for this one here, you have an exponent. When you have an exponent after a logarithm, you can really put it down in front. And so then it's just the log times that c in front, which was the exponent. Now, if you have the log base a of two things added or subtracted, there's really nothing you can do with it. We're going to use those properties of logarithms to rewrite this in terms of x, y, and z. You now have the log of two things divided. So from what we were just looking at, you should be able to take log of the top part minus log of the bottom part. Well, now as you look at this, you should realize that, oh, I now have the log of two things multiplied together here. So I should be able to go log of the first one plus log of the second one. We still have our subtraction sign. We also have log of two things multiplied together here. So we should be able to go ahead and go log of the first one plus log of the second one. And if you don't have the parentheses here, you'll end up getting the wrong answer. Because to get rid of the parentheses, you'll have to distribute through the negative. We now need to work with our exponents. Our square root here at the end is a fractional exponent of 1/2. We can use the clog rule from the previous page that says take your exponent and put it down in front. Take your exponent, put it down in front. Take your exponent, put it down in front. Take your exponent, put it down in front. And here, in addition to putting it down in front, I also distributed through the negative sign, so that's why we have a negative here. Now you notice the directions said to write it only in terms of x, y, and z. And you'll realize you have the log base a of a here. But if you remember carefully, that really means your base of a to what power gives you a. You should remember that that means 1. So it's a 1 times your 2. On this problem, we're basically doing the reverse process. We want to combine all these three different logs into one log. Well, the last thing we did on the last problem was deal with exponents. So we got to go ahead and take the things in front of our variables up as exponents. When we take them up as exponents, we can now do the next thing. I'm going to go ahead and pull the negative out of the last two. Then I end up with a log plus a log. Remember, when you're adding logarithms, you can go ahead and write it as one logarithm, and then instead of adding what's after, or adding two logs together, you multiply what's after. So after the first log is c, after the second log is m to the fifth. We now have a log minus a log. According to our properties of logarithms, a log minus a log, all we have to do is to go ahead and divide what's after the log. So you write 1 log of base a, divide what's after your log. So you take what you had to begin with, and then what was after the second log you put in the denominator. Well, your 1/2 power is really just a square root, so you could write it like this. Now we're going to go ahead and use our properties of logarithms to help us solve logarithmic equations. Logarithmic equations are just equations with a logarithm in them. Here we have a log plus a log. Your properties of logarithm says take what's after the first log and multiply it by what's after the second log. If we distribute our x through to each part, we would get this. Now we've looked at before solving problems like this where we have a log and a variable after it, and what we did was we put it in the other form. We put it in the exponential form. Remember, to get it in the exponential form, you'd want to take your base of 2, swing it over to the other side, and it hits that 3 up as your exponent. And when you do that, your log drops. Now we just have a quadratic equation, so we'll solve it like a normal quadratic equation. Set it equal to 0, and then in this case it actually does factor. Set each one of these factors equal to 0. Now, our only answer here is x being 2. We're not going to use x being the negative 4 because when we put negative 4 in here, we get a negative after a logarithm. So basically, when not all the terms have logs, you want to reduce the whole equation down to a single logarithm. Then put it in the exponential form. Here we're looking at everything having logs in all the terms. You want to reduce each side down to a single logarithm. Left side is already that. Right side's a log plus a log, so you multiply it as 1 log and multiply what's after them. Your 5 times your 3 is your 15. A log on each side then, 1 log on each side, then you can drop your logs, and then you solve it just like a normal equation. And then we would get 13 over 3. You then also want to check, does my 13 over 3 cause me to get a negative after my log? 13 over 3 times a 3 plus a 2, definitely not going to be negative. It'll be positive, so it'll work. So, when not everything has, or everything does have logs, you reduce each side down to a single logarithm and then drop the logs. A lot of people will try to drop the logs before they reduce each one down to a single logarithm, and that will lead you astray.